my document cam is running. So this is the answer to 1A. The answer to 1B is negative 10.8 meters per second squared. The answer to 1C is 3.0 seconds. And D, we're working on right now. We're using the quadratic equation to find T. And it should come out to be 6. You'll get two answers. One will be negative 10, the other will be 6. We're waiting to confirm the results. How you doing, Charlie?
Go.
Did you get sick yet?
No, I can just do this later.
Are you sure? Because
yeah, I'm just doing it.
Okay, but everybody else is doing it too. This is important, and we have time. So you might as well put it in because you're going to need it. We have to figure out how to find it. We're going to do it together.
I think I know why your thing didn't work. Are you in the complex number setting for your mode?
I'll check.
Because on your video it says you have to change that before you can do the quadratic.
Okay, I'll check.
So what was it? It was negative 4.9. got 2.04.
2.04? Ah. I got 6. What did you get? Michael?
I don't know the numbers. I got it done.
Are you still right in the program?
No, I got it done. I just don't know the numbers for it.
Oh. So you're going to put in negative 4.9 for A, negative 20 for B, and negative 300 for C. Trey, how are you doing?
More fun program.
We got like 2 negative 2.04. Yeah. So I wonder if it's a negative.
Try on positive.
It already accounts for the negative. No, so you still get the same.
You got 6.
Why did I get 6? What did you get?
I think we had these two much better than 6. That's what that was.
Yeah, those are like the, you know how it's like plus or minus because it's a,
Yeah.
that's like what it's accounting.
So it would be like 6 and 10, maybe 10.
So I'm going to go back and check that one. Okay, shall we go on?
Because I set it up the right way.
Yeah.
So we got to do this.
Okay, so onward. Charlie, what did you get? Anything? Okay. Is it okay if we move on?
Yep.
Okay, number 2. Number 2, we're throwing a rock up in the air. And it has an initial speed. So it says it wants a well-labeled diagram. So we're going to have the error. And we're throwing a rock up, straight up in the air, and it's going to come straight back down. So it has an initial velocity. It has a height. So we're doing this just to get you used to drawing things. When it hits the ground, right before it hits the ground, it has a final velocity. But understand that it could be a final velocity at any specific time also. So that right there would be A. Okay, B, it says make a list of given quantities. So you should always have a list. So our list is VI is 15. G is negative 9.8 meters per second squared. Y. And VF. So if it's hitting the ground, VF will be 0. And since it's going up, this is positive. And notice that this is a parabola, so if you have if you know the ball's velocity here, you automatically know the velocity there. It's just in a different direction. And it says, what is the acceleration of the rock? So the acceleration of the rock is negative 9.8. Okay. It says calculate the rock's height after 1 second. So I'm going to use this equation. I'm just writing in the quadratic form, okay? Oops. So here your y should be 10.1 meters. Did you get that? Did you guys get that or not? No?
Yeah, I got that.
Okay.
I got that.
I just don't want you to think that VF is when it hits the ground. So make sure you don't have that thought in mind. So I'm going to use VF equals VI plus KT. And then I'm going to solve for T.
You got us
In here?
and on the board.
Yes, I squared the 1. Does that make sense? And 1 squared is 1. Okay, so notice this is positive, so this is going up. So we're still going in a up stage. Oh, rats! I screwed up. So I got 1.122 seconds. Alright. This says calculate the time required to reach a downward speed of 5 seconds. So here our negative is going to be in front of the 5. So now we're on the other side of the problem. So you have to be able to visualize that with these problems. So you have to know where you're at in the parabolic path. Does that make sense to you, Charlie? Charlie? So we use the same equation. Putting my numbers in. The answer is 2.04 seconds. Hoping that this time is higher than the other time because it's on the downward one, so it should be higher, right? So we have to use common sense with these. So that's where we stand on number 2. So let's look at number 3. Turning the page. We had a ball punted up. Here's what I have here for this. So I have a nice picture and my equations. So the total time is 3.8 seconds. So if I ever wanted to figure out how high it went, I would take that time in half. And realize that the top of the path of the parabola, what is VF at the top of this parabola? 0. So make sure you write that down. Don't forget that your VF at the top of the parabola is 0. You can use that to find the height. That is a very, here we don't have to. I'm going to do something funky though. I'm going to say, hey, when the ball reaches the ground is 0 meters. So I want to know the total time at 0 meters. And so that was the trick I used in that problem. Because this problem had a lot of question marks. And that would make people flip out. And they're like, oh, I can't do this problem. You can if you make the assumption that y is 0 at total time, which it is. You're sitting on the ground. So if you go ahead and do that, you get 4.9 for that one. Okay. And number 4, there was no math involved in number 4. Number 4 was all a review. We touched on this. This is something that you did in your lab on Monday. You all had a vehicle parabola. You took the you took this parabola and you changed it into a straight line by squaring it, by squaring the y-axis. And then you found the slope of that line. It should have been negative 9.8. Yours wasn't. Why wasn't yours negative 9.8? There's outside factors, just like wind. There is the ball. There's like roughness on the ball. The ball's turning. So we're not living in the perfect little world that we're normally used to living in. In this problem, we are. So that's kind of nice. So then that takes us to the next page. The next page is number 5. So here's where we're at with number 5. So we have a student throwing a baseball. So what are your thoughts on that? It says, how long does the baseball take to hit the ground below? So what, so the student is throwing it off of a bridge. So here's our bridge. The ball is going like this, right? It has an initial velocity, right? And it has a initial downward speed. So we know how high the bridge is. We know the initial velocity is negative 10 meters per second because it's going down. And it says, how long does it take the ball to hit the ground? So what is y going to be when the ball hits the ground? 0. Okay, you can go that route, or since I have, well, I don't have VF, so I'm going to have to use that route. I'm going to assume that y is 0 at the bottom. So I'm going to put 0 there. My initial velocity is negative 10. We have t. Okay. You could. You want to try that?
Sure.
Let's look at B. It says, how fast is the ball going at the moment of impact? So at the moment of impact, you could say VF equals VI plus GT. We don't have time, so that is not an option. However, we could use VF equals VI squared plus 2GY and find VF there. So that's going to work for us. Okay, and VF comes out to be what? It's going to be negative. We're going to have to be certain to put that negative sign in there because it's going down. Does anybody want to share their answer? Naomi, what did you get?
I got
49.5. So Charlie, do you agree with that? 49.5. Put the numbers in and see. Okay. I too got that. Then that's the work here. Okay, good job. Okay, now do you see how I had to put that negative in there? Because if I want to put the negative in there, I would have to put in the I, and I make sure it's complicated. Do you remember what I is? That's a complex number.
Oh yeah, it's like
I squared is negative 1. Was it?
yes, I always got the problems for.
Okay, so now, based on Charlie's brilliant idea, we don't have to do a quadratic here. So there's more than one way to solve these problems. Here you can use a quadratic, and do the quadratic and use your program that you did on your calculator. Or you could take your thing here and go back and use VF squared, or this one equation here. And solve for t. Because now we have the VF. So let's go ahead and do that rather than the quadratic, because I know not everybody has it in their calculator working properly. So our VF is negative 49.5 minus negative 10 divided by a negative 9.8. And what does t come out to for you?
4.0.
4.03. Is there an agreement on that?
I agree.
Yay! We love agreement. Let me see if I agree. Yes. Okay. Number 6. It says when a kid drops a rock off the edge of a cliff, it takes 4 seconds to reach the ground. So we have just a falling sphere. So negative infinity. Initial velocity, vf, y, and t. So it says it takes 4 seconds to reach the ground. So that's total time. So not a parabola. Oh, I'm sorry, Tyler. Okay, so then she throws the rock down, it strikes the ground. When she throws the rock down, it strikes the ground in 4 seconds. So this initial speed does she give the rock? Okay, so we have 2 situations here. So we have situation 1 where it's just dropped and our initial velocity is 0. Okay? So we can use this situation right here to figure out how high the cliff is. Then we can use the height to figure out the initial velocity in our second situation. So it's a double problem. So I have to do this one to get that one. Okay? So I don't necessarily need to know how fast the rock was when it hit the ground. But I do need to know how high the cliff is, because it doesn't tell us. So, with that, how can I do that? Do I have everything I need to figure out why in this situation?
Well, you have to find the y first for the cliff.
You're right.
And then you have to.
And what do you get for y in that situation?
I got negative 78.
Negative 78 meters. So then we'll transfer that over here. And then I can use what to figure out the VI here. We're going to use the same equation?
I use the same equation. I just like moved it around.
Okay, so we're going to solve for VI. So I'm going to take y minus 1 half gt squared and then divide by t. So y is negative 78 minus 1 half negative 9.8 times 3 squared, which is 9, over 3. So what do you get for VI there?
I got negative 41.
Negative 41. Did we agree on that? Charlie, did you do that?
Nope.
Is that what you got?
Yep.
Okay. Are we sure? Because I got 12.
Maybe. I don't know. Just I'm doing this.
Negative 11.3.
Okay, so you got close to 12 then too, huh? Okay, so I think I have a math problem. So negative 78 minus parentheses 0.5